What's up, you freaking geniuses? So in this video, I'm going to teach you how to graph logarithmic functions with transformations. And I'm also going to show you how to find the asymptotes, the domain, and the range. And in case you need a refresher on how to identify all the basic transformations of logarithmic functions, I'll link a video to that in the card above and description below. But I'm still going to cover most of them in this video. All right, let's start with this one right here. F of x is equal to log base 3 of x. Now, the first thing I want to mention is our asymptote, actually, because all of our logarithmic functions always have an asymptote right here at x is equal to 0, or in other words, right along the y-axis. And that's true unless we move or shift the graph left or right. Okay? Now here, the first thing we can do is rewrite f of x as y is equal to log base 3 of x. Now, the goal here is to solve for x, kind of isolated by itself. So we need to get rid of the log base 3. And the way that you can do that is by whatever number you have right here, the base, just put it right here. So we're going to say 3 raised to this whole thing, and we're going to say 3 raised to this whole thing. So then over here, we're left with 3 raised to the y is equal to, and then on this side, this 3 and this log base 3 cancel each other out. And all we're left with is this x. All right, cool. So now that we solved for x, we have this in exponential form, right? We can just make a little xy table. And in this case, instead of plugging in numbers for x, you want to plug in numbers for y, right? Because y is what's in our exponent. So then we can just see what pops out for x. So we'll just pick some easy numbers. Let's say -1, 0, 1, and 2. So if we plug in a -1 for y right here, we'll get 3 raised to the -1, and that's equal to 1/3. Okay, so we get x is equal to 1/3. Now if we plug in a 0, we'll get 3 raised to the 0. Anything raised to the 0 power is just equal to 1, so then we'll get 1 right here. Plug in 1, so we get 3 to the first power, which is just equal to 3. And then if we plug in a 2, we'll get 3 squared, which is equal to 9. Okay, so now if we plug our points, we're going to get, let's see, 1/3, -1 is about here, 1, 0, let's see, 3, 1, and 9, 2. Okay, so then we'll just connect the dots, and I'll clean this up a little bit. All right, so there's our graph. Now, lastly, let's talk about the domain and the range. So the domain is just our x value, or our x limits. So we're going to go from 0 all the way to positive infinity, right? So we're going to write it as 0 to infinity. And for the range, it's always going to be the same for all of these. It's always going to be, you can write it as all real numbers, or you could say from -infinity to positive infinity like that. Okay, next we have y is equal to -log of 5x. So first, let's identify the transformations here. So first, you can see there's a negative sign out here in front of the log. So whenever we have a negative sign out here, that means there's a reflection in the x-axis. Okay, so we can just say there's a reflection in the x-axis. Now, the other thing going on here is there's another number being multiplied by this x, right, inside of these parentheses. And when you see a number in here, this indicates a horizontal stretch or shrink. Now, if this number is bigger than 1, like in this case, then we have a horizontal shrink. Okay, and it would be by a factor of the reciprocal of this number. So the reciprocal of 5 is 1/5. Okay, so those are our two transformations. Now let's graph this. So one thing you might have noticed is that there's no little number, right? There's no base right here. So whenever there's no number there, it's implied that there's actually a 10 right here. So if you wanted to, you could rewrite this as y is equal to -log base 10 of 5x. All right. Now we're trying to solve for x here, right? Write this in exponential form. So the first thing we can do is get rid of this negative sign, right? So we can just divide this side by -1 and this side by -1. So over here, we're going to wind up with -y, and that's equal to log base 10 of 5x. Now, in order to get rid of this log base 10, all we have to do is, again, take this base, so 10. So we're going to say 10 raised to this whole thing, and what we do to one side of an equation, we do to the other, right? So we're going to say 10 raised to this whole thing. So then we're left with 10 raised to the negative y is equal to, then over here these cancel out, and we're just left with 5x. Okay, and then here we can get rid of the 5 by dividing both sides by 5. Those cancel out, so then we get that x is equal to 10 raised to the negative y over 5. And also we can't simplify 10 over 5, we can't reduce that down to 2 or 2 over 1, specifically because we have an exponent attached to the 10. So this is as simplified as we can get it. All right, so now let's just make a little xy table. And I'll rewrite this just to simplify. So x is equal to 10 raised to the negative y over 5. So again, let's plug in some numbers for y and see what pops out for x. So for y, let's plug in, let's say -1, 0, and 1. So if we plug in a -1 here, we're going to get that x is equal to 10 raised to the -1 over 5. So that's equal to 10 raised to the positive first power, which is just 10. So we get 10 over 5, which is equal to 2. All right, now if we plug in a 0, we'll get that this is equal to 10 raised to the -0. But really, there's no such thing as positive or -0, right? So this is really just equal to 10 raised to the 0. And then remember, we're still dividing by 5. Anything raised to the 0 power is equal to 1. So then here we get 1 over 5, so 1/5. All right, and then lastly, let's plug in a 1. So we'll get 10 raised to the -1 over 5. So 10 raised to the negative first power is the same thing as taking the reciprocal and then just turning the exponent positive. So 10 raised to the -1 is the same thing as 1 over 10 raised to the positive first power, and then we're still dividing by 5. Okay, and I'm going to make a little room here so we can solve that. So we have basically 1/10 divided by 5. We can rewrite this as 1/10 divided by 5. Now, in order to divide by a fraction, you have to multiply by the reciprocal, right? So then this is going to be equal to 1 over 10 times, and then take the reciprocal of the second number, which is 1 over 5. So we get 1 over 50, right? So then 1 over 50. Okay, so here are our 3 points. So 2, -1, 1/5, 0, and then 1/50th, 1. Okay, so we're really close to the y-axis here, right? That we're not actually going to touch it. So if we play connect the dots, our graph is going to look something like that. Okay. Now remember, the original function over here, these were our only 2 transformations, right? We didn't shift it left or right. So that means our asymptote is always going to be right here on the y-axis. So again, at x is equal to 0. Okay, so then if we talk about the domain and range now, let's see, the domain is going to be our x values, right? So from 0 to infinity. And the range, again, is going to be all real numbers, or from -infinity to +infinity. All right, now we have y is equal to 2 times log base 1/2 of x plus 4. So again, let's first identify the transformations, and then we'll graph it, all right? So as you can see, we have an additional number out here in front of the log. So when you see a number out here, that indicates a vertical stretch or shrink. Now, if this number is bigger than 1, then that would be a vertical stretch. Okay, and if it was less than 1, it would just be a vertical shrink. Now, the other transformation happening here is inside of these parentheses. So you can see we have x plus or minus some number. So whenever you see this, that indicates a shift left or right. And you always want to take the opposite number that's in here. So since there's a +4, we actually want to move -4 spaces, or in other words, 4 spaces to the left. Okay. The other thing I want to point out here is that this number also tells us where our vertical asymptote is. So it's going to be at x is equal to -4. So we can already draw that in, right? So our asymptote is right here. Okay, so those are the transformations. Now let's graph this. So let me rewrite it just so we can see a little bit more clearly what's going on here. Now, again, the goal is trying to solve for x, right? So we want to rewrite this in exponential form. So the first thing we can do here is get rid of this 2 by just dividing both sides by 2. So then we get y over 2 is equal to log base 1/2 of x plus 4. Now again, in order to get rid of this log base whatever number, remember just take this number and we're going to say 1/2 raised to this whole thing, and we're going to say 1/2 raised to this whole thing. All right, so then we're left with 1/2 raised to the y over 2 is equal to, and then those cancel out, x plus 4. And I'm going to make some room. Boom! All right, now the last thing we can do is move the 4 over, right? So then we're going to have 1/2 raised to the y over 2 minus 4 is equal to x. All right, so that's what it looks like in exponential form. So now we can make our table. And again, we want to plug in numbers for y. So some easy numbers we can plug in for y, in this case, are going to be -2, 0, and 2, right? Because our denominator is 2, so that way we can use 2's to kind of give us an easier exponent to solve. So if we plug in the -2 for y, we're going to get that this is equal to 1/2 raised to the -2 over 2 minus 4. So that's equal to 1/2 raised to the -1 minus 4. Again, we have a negative exponent, so we'll just flip this and turn that positive. So this is equal to 2 over 1, which is just equal to 2. So 2 to the first power minus 4, so that's equal to 2 minus 4, which is -2. Now let's plug in a 0. So here we'll get 1/2 raised to the 0 over 2 minus 4. 0 over 2, that's equal to just 0, and anything raised to the 0 power is just equal to 1, right? So then this is all equal to 1 minus 4, which is -3. All right, and then lastly, if we plug in a 2, we'll get 1/2 raised to the 2 over 2 minus 4. So that's 1/2 raised to the first power, right? So then we're just left with 1/2 minus 4, and that's equal to -3.5 or -3.5. Oh, okay, so our 3 points right here are -2, -2, -3, 0, and -3.5, 2. All right, so then we'll draw our graph. Cool, so there's our graph. Now lastly, the domain and the range. So the domain this time is going to change, right? Because we moved the asymptote to the left. So this time it's going to go from -4 to infinity. All right, and then the range is still going to be the same thing, all real numbers. All right, last one here. So y is equal to log base 1/3 of -x plus 6. So again, let's identify the transformations first. So here you can see that we have a negative sign or a negative symbol inside of our parentheses, right? So we have a -x. So whenever you have a -x, this indicates a reflection in the y-axis, okay? And you can also see we have another number at the very end. So whenever you add or subtract a number at the very end, that just shifts your graph up or down. So in this case, we would have a translation that is up 6 spaces or 6 units, all right? So those are our 2 transformations here, right? So now let's graph this. So again, I'll just rewrite it. So we have a little bit clearer of a picture what this is. Plus 6. All right, so we're trying to solve for x and rewrite this as in exponential form. So first we can get rid of this 6. So we're going to have y minus 6 is equal to log base 1/3 of -x. Now in order to get rid of this log base 1/3, again we can raise this whole side. Right, so we're going to say 1/3 raised to this whole side and 1/3 raised to this whole side. So then we're left with 1/3 like that, raised to the y minus 6 is equal to, and then again these cancel out, equal to -x, right? Now lastly, we can get rid of this negative sign by either dividing by -1 or multiplying by -1, but in either case we're going to get -1/3 raised to the y minus 6 is equal to just x, all right? So that's our final function in exponential form. All right, so now let's graph these guys. So here's our table. Now, some easy numbers we can plug in for y. Let's see. Let's say 5, 6, and 7, right? Because those are all somewhat near 6, or they are near 6, right? So then we'll have kind of a smaller exponent to evaluate here. So let's plug in a 5 first. So here we're going to get negative 1/3 raised to the y minus 6. So we're going to say 5 minus 6, and that's equal to negative 1/3 raised to the negative 1. So 1/3 raised to the negative 1 is the same thing as 3 over 1, or simply just 3 raised to the positive first power, right? And then we still have this negative sign out here. So 3 to the first is just 3, so negative 3 is our answer. So we get a negative 3 right there. Okay, now if we plug in a 6, this is going to, I'll move it down a little bit, this is going to be equal to negative 1/3 raised to the 6 minus 6, which is equal to 0. Right, so negative 1/3 raised to the 0 power. Anything raised to the 0 power is equal to 1. So this is equal to 1, right? But we still have our negative sign out here, so don't forget to bring that down, so negative 1. All right, and then lastly, if we plug in a 7 here, it's going to be equal to negative 1/3 raised to the 7 minus 6, which is equal to 1, right? So negative 1/3 raised to the positive 1. So then this is equal to simply 1/3, and then again our negative sign right there. So negative 1/3. Okay, so let's plot our points. So negative 3, 5 is right there. Negative 1, 6 is right there. And negative 1/3, 7 is about right there. Okay, now if you remember our two transformations over here, we didn't shift this graph left or right. So that means that our asymptote is again right here on the y-axis. Okay, so then if these are our 3 points, we can just connect them like that, and then we're going to go sharply straight up like that. All right, so there's our graph. Lastly, the domain and the range. So let me make a little bit of room down here. So the domain and the range. So the domain in this case are our x values. So you can see we're coming from basically negative infinity and coming all the way this way up until we hit the asymptote at 0, right? So we're going to say the domain goes from negative infinity to 0. But we're not including 0, so we're putting a parenthesis, okay? And then again, the range is going to be all real numbers. So if you found the video helpful, definitely leave a thumbs up down below. And if you have any other questions or want to see any other examples, just let me know in the comment section below.